Hello everyone, welcome back to another video for the series. I'm Q, and today I came back with another very interesting problem from Baltic way again. And yes, I really learned a lot from this problem, so I also wanted to share it with everyone. So we need to prove that for a sub I, positive real a sub I, that satisfies this, we need to prove that this inequality is true. Yes, I spent a lot of time. I think I spent like 3 to 4 hours trying to solve this problem, but didn't make much progress. Yes, so I had to look at the solution, and I think the solution itself is so brilliant, and we could actually extend this problem too. So we could change like the 2023 into n. I believe it's 2023 because this problem was in the year 2023. But I think after solving this problem, I may change the problem again with n, so that we could solve more extended or more generalized problem. So first, we're going to restate our problem. So if we prove that, let's take the contrapositive of it. So we need to prove if a sub 1 2023 plus a sub 2 to the power of 2022 plus all the way until a sub 2023 is less than or equal to 1 plus 1 over 2023, then plus a to the square plus now is not equal to 2023. So if we prove this, then we prove our statement here, because this is the contrapositive. If this, then that. If not this, then not that. Now, not equal to 2023, I think, yeah. So what we're going to do here is we're going to prove something similar, but quite different. So we're going to actually prove, we're actually going to prove, we're actually going to prove this one is less than 2023, because if this thing is true, then this is automatically true, because if this thing is less than 2023, it's not equal to 2023. So if we prove this to be true, then this is automatically true, and because this is true, its contrapositive must also be true. So we just need to prove this one. So how should we do it? Notice that, let's start. Notice that if a sub I for any number is less than 1, then the statement is true. Moreover, if more than 1 a sub I are greater than 1, then or equal to 1, the condition does not satisfy. One greater than or equal to 1, the assumption is false. Is false. Therefore, it suffices to prove the case when one a sub I, when one a sub I is greater than or equal to 1. Because if they're all less than 1, it works. But if more than 1 are greater than or equal to 1, our assumption right here does not work, so we don't really have to care about it. So the only case left is when one a sub I, it could be a sub 1, a sub 2, or anything, is greater than or equal to 1. So let's prove that case. So we know that. Let's say that a sub I is greater than 1. So if a sub I is greater than 1, then notice that a sub I to the power of I, if a sub I is greater than 1, it must be less than 1 greater than or equal to 1. They must be less than 1 over 1 plus, because this is because a sub I or anything else, a sub j, is a positive number. So this must be true always. That means a sub I to the power of I, and we are going to do this because we have something to the power of I here. What's going on here? A sub 1. So we know that this is less than 1 plus the power of I. And notice that this is greater than 1, and I is always less than or equal to 2023. So this is less than or equal to 2023. Because I is less than or equal to 2023. We know that this is true. Let's compute more here. We're going to use binomial theorem here. So we know that this is equal to, when k equals 0 to 2023, 2020, wait, is it 2020? 2 to the power of 2023. Oh, it's k. 1 to the power of 2023 minus k times 1 over 2023 times to the power of k. Did I do it correctly? I believe yes. No, but why do you have 2024 terms? No, this is quite strange because I think no, this is right. This is right. I should not be confused with binomial theorem. Yeah, this is right. And we don't have 2024 terms. We added all the terms, and yeah. Okay. Anyways, simplifying, this is equal to when k equals 0 to 2023, the power of k, this is equal to k equals 0, 2023 factorial, k factorial 2023 minus k factorial over 2023 to the power of k. Now let's start our index from 1, because when k equals 0 is 1, so we can write it like this. And the reason why we want to start it from 1 is because that way we can change this thing like minus k plus 1, because if we started from 0, we cannot do from we cannot do +1, so we cannot change this into this form, and it will be awkward if we don't have this +1. It would just not make sense. Oh, what am I doing? Sorry. 2023 over 2023 times ... until we have 2023 minus k plus 1 over 2023. Yes. And obviously we have k of 2023 here, and how many of them do you have? Subtract and plus 1, so we indeed have k terms on top and bottom, so this works. And notice that this is obviously less than 1 plus 1 over k factorial, because these things are less than 1. Now this thing is also less than 1 plus k equals 1, no, 0, 1 over 2 to the power of k, and that's because, let's match this, so we have 1 over 1 plus 1 over 2 times 1 plus 1 over 3 times 2 times 1 plus until we have 1 over 2023 factorial. We have 1 over 1 plus 1 over 2 plus 1 over 2 times 2, so ignore the ones. Then matching them, we have 2, 3 plus 1 over 2 times 2 times 2. You will match with 2, 3, 4. And how many terms do you have here? 2023. How many terms do you have here? 2023. So actually they all matches together. Yeah. So we know that this is true. So this is the same thing as, what happens if we use our geometric series? We get this one, 1 minus 1 over 2. That's a formula. This is the same thing as 1 plus 1 minus this is not right. What? No way. Oh, it starts from 1. Then we have this 2, and this should be 1. This is, oops, this is less than 3. Therefore, we know that a to the power of I, the power of I is less than 3. Great, because we're going to do something smart here. 1, k equals 1 to k not equals I until, yes, and I'll explain why we stop in 1011. This is obviously less than, because each a sub k for k not equals 1, from 1 through 1011 is less than 1. Must be less than when they're all equal to 1, which is this one. Now this is true. How about the rest? So k not equals I until 2023 k. Now this explains why we split it into half, like almost half, because notice that this is less than or equal to not equals I k 2024 minus k. And here's why. Because okay, so this thing is should we match them? So like a to the power of plus plus and we have here we have plus plus. Yes, notice that this is obviously less than or equal to. It's less than. They can't be equal to each other. This is greater. Right? Wait, what? Oh yeah. So sorry. So this is greater because notice that this thing is greater than this thing. This is greater than this one. So each term like is greater than the other with its pair because a sub k for k not equal to I is less than 1. And the graph looks like this. Yeah. So this is true. And the reason why we should have stuff from 2011 is because if we went like more, so let's say that we started from like, I don't know, like 1000, here 1000, 1000, but our term here is actually a to the power of a sub 1000 to the power of 1024. Now, we don't know if they will actually balance or if this thing will be greater. So this does not ensure this inequality right here, because we know that this is greater than this one and the rest is greater than this one. I mean, this is greater than the rest, while this one is greater than this one. So we don't know. It quite depends, and we don't want to think about each case. It's quite impossible to think about them. So this ensures our inequality right here. And let's use our if condition right here. So this is obviously less than k equals 1 2023 is k 2024 minus k minus a sub I. Yes, it's obviously less than. Yeah. Yeah, it's obviously less than that. And this is less than or equal to 1 plus 1 over minus a sub I to the power of I. Now notice that because this is 1 point something, this is less than or equal to 1 over 2023. Because a sub I could actually be equal to 1. We don't know. Yeah, so this is true. Therefore, k equals not equals I. A sub k is less than 2023. Now let's merge all the information that we know. K equals 1011. Oops. K not equals I. 11 plus not equals I. K. Oh, I forgot to write it. A sub I plus I this is less than 1011 plus 1 over 2023 plus 3. Now this is less than 2023, obviously. And what is this equal to? We have 1, 2, 3 all the way until 1011, and it continues from 1012 to 2023, excluding when a sub I to the power of I, but we added here. So it is the same thing as a sub 1, 1 plus a sub 2, 2 plus all the way until a sub 2023, 2023 less than 2023. And that proves that's the same thing that we have here. So if this is true, then this is true. We just proved it. So that proves our inequality right here. Now, yeah, this is somewhat obvious but also quite interesting because we use the contrapositive and like logic to restate our problem, and then we split it our sum. Now, what if this is equal to n, not 2023? Then it would be the same thing, but let's consider this the other way. So if this is n, let's change everything to n. So a sub n to the power of n equals n, and n minus 1, yeah, and then 1 over n. We do the same thing. We find the contrapositive and use logic. So if we prove that a sub I to the power of n plus all the way until a sub n is less than or equal to 1 plus 1 over n, then, or I might just write it in red, n minus 1, n minus 1, n minus 1, n minus 1, n. So obviously for a sub I less than 1, the statement is also true. Yeah. But if more than one a sub I are greater than or equal to 1, the assumption is obviously false. It's the same. What is this? Therefore, it suffices to prove the case when one a sub I is greater than or equal to 1. Then, yeah, this is true. And binomial theorem is much easier to use binomial theorem here. Now let's take a look at this case. This is true. How many? We have k of them, k of them. So this is true. Yeah. So this is also true. So we know that this is true, and yeah, this is quite tricky. Let's change this to yeah, so if n is an even number, we go with n minus 1. I mean n over 2. But if it's odd, we go with n minus 1 over 2. So it's either n or n over 2 or n minus 1 over 2. So this is also n or n minus 1 over 2. Let's take a look at these cases. So it's n, and this one is either n over 2 or n plus 1 over 2. So looking at them, we have or n plus 1 over 2. It should be n plus 1 here because it starts it ends with 2023. I mean it ends with n. So n plus 1, n plus 1, n plus 1. So okay. Let's say that it's n over, let's say that n is an even number. If n is an even number, we change this into yeah, n over 2, k equals 1, k not equal to I. This is n over 2 plus a sub I. And this is less than n over 2 plus 1 over n. That was proven. Is n over 2 or n plus 1 over 2. It's just n here. Yeah. Sorry, it's just n here. Yeah. Yeah, because there is 1 over n because you have 1 over n here. Oops. Plus 3 is, 3. So, and notice that this thing is less than n, obviously. For big n's. Wait. No way. What if n equals 1? Huh? N equals 1 is true. What? Okay, we consider the case because we know that n equals 1, n equals 2, they all works. They must work. Yeah. How about n equals 3? It should also work. Yeah, when n equals 3, it should also work. So when this gets asymptotically large, so like greater than like 1,000, 10,000, this is true. And notice that we have from 1 through n over 2, and then we have we need to subtract the case one more time because we added too much. Let's go with 1 plus n over 2. And let's go with 1 plus n over 2. Yeah, I think that's right. Yeah, we should actually go. No, it's 1 over 2. N over 2. Yeah, this should be n over 2. Then let's go like this. As minus 1 and minus 1 over 2 minus 1. That way we get minus 1 and then from m minus 1. Yeah. So this makes sense. This makes sense. So it actually counted every case. What am I saying? It should go on to n. Sorry. No, we counted from a sub 1 through a sub 1 to the power of 1 to a sub n to the power of n. We added all the all the terms, and know that it is less than n. This is equal to n over 2 plus 1 over n plus 2. Yeah. So this is the case when n is really big, because obviously when n equals 1, we don't really have to use this method. We know that this works. It works. How about n equals 2? When n equals 2, it also works. Because yeah. N equals 3. How do we generalize it? Yeah, I think we can generalize it like this when we have like something. So let's just try. When is this less than n? Plus, let's just solve this. Two plus or minus square root of b squared minus 4ac minus ac over minus ac. Yeah, so this implies that when n greater than 1, 2, 5. Yeah. 1, 2. Yeah, for the case when n is greater than or equal to 5, we can generalize it. But from when n equals 1 through 4, or like n equals 2, 3, 4, we actually need to try like just from here. But obviously when it's n equals 2, this should work, because we have a sub 1 plus a sub square equals 2023. It must be greater than 1 plus 1 over... Oh, sorry. It equals 2. Is this true? Yeah, we actually need to, I think, to generalize it, we need a condition that n is greater than or equal to 5. That's the condition that we need. So n greater than or equal to 5. Okay, now the next case was when it was when n is an odd number, right? Then we consider n minus 1 over 2. We have n starting from m let's just subtract 1 here. Minus 1 over 2. That way we count everything. We counted everything. Now this thing is less than n minus 1 over 2 minus 1 plus 1 over n. Yeah, 1 over n plus 3. Now, obviously, this is less than n for n greater than 5. So, yeah, greater than or equal to 5. So when it's 5, this is 2, 4, yeah, it should work. Or to be precise, let's calculate it one more time. But no, but we don't really have to calculate it because this is true for n greater than or equal to 5. And obviously, this is greater than minus 1 over 2 plus 1 over n plus 2. Yeah. Nice. So that's the generalized form. So it always works when n is greater than or equal to 5. Now we really need to consider it when n equals 2, 3, 4, because yeah, maybe I might leave them for the next video or something. So yeah, I learned a lot from this problem and I also enjoyed it a lot. I hope you also enjoyed it and found this poem really valuable. Thank you, and I'll come back with another very fun and interesting problem tomorrow. Thank you, and see you tomorrow. Bye.